Welcome back to High Noon Racing, y'all, and do I ever have a video for you.
This weekend, we're diving deep into what makes the Heart of Scoots backyard Firebird project, and hopefully soon, an 8-second beast, boost control system work. You already know, I got my boy Chuck here to lend a hand or offer questionable advice.
Hey bro, ain't nothing questionable at my advice. I'm just here to make sure that you're not turning this thing down, because this is a kitchen sink motor. It gets all of it every time.
Sink motor?
Throw the kitchen sink at her.
What if I wanted to last a little bit?
Nah, dude. LSs are cheap.
Oh, I don't know about cheap there, brother. I don't know about that. Anyways, today we're covering everything. Plumbing these dual wastegates, setting up the onboard air system, wiring and configuring the MAC valves, and then dialing it all in with the Holley Terminator X. Oh, and we're going to show you Boost's biggest enemy, boost leaks. Stick around, you're going to learn a ton, and hopefully we'll get Scoots one step closer to that 8-second slip. That's enough yap, let's get to it. We're running VS Racing 44mm Gen 2 wastegates. And the springs in here right now give us our base pressure, our absolute minimum boost. For Scoots, that's 18 PSI.
Yep, you heard that right. 18 PSI base pressure, because we do like to party. But we do not recommend starting out on party mode. If you're bussing and you're just starting out, you should target 5 to 8 PSI of base spring pressure.
Bussing?
I don't know, dude. I wrote this. I don't know. I don't know, man.
We're gonna have to just eliminate that last sentence.
Now, to control these wastegates precisely, especially for things like launch control, or boost by gear, and our favorite boost over time, we need a consistent air source. That's where our onboard air system comes in. We've got our $170 Amazon Vi Air compressor tucked away here,
which works surprisingly well for a 1-gallon tank.
It came with our air tank, pressure switch to tell the compressor when to kick on and off, and all the wire. But we did have to get this pressure regulator separately. This regulator is super important to have. This guy ensures our MAC valves see a consistent set pressure no matter what the tank pressure is. We usually set these between 30 and 60 PSI. Now these right here, this little guy is the brains of the air operation. The MAC valve, aka boost control solenoid. The Holley ECU tells this valve how much pressure to send to the top of the wastegates and how to control it.
Commonly referred to as dome pressure.
Alright, it's visual aid time, and Chuck, you're on pointer duty.
Dude, look at that crusty finger.
Thank you, sir.
Alright, thanks Chuck for lending a hand here. Okay, so we're going to start over here at the compressor, where it's going to make all the air is then going to be at like 125, 35 PSI. The regulator's going to knock it down to like 160, or I'm sorry, 60 or 30, and then that's going to feed into, it don't matter how you do these, you can feed it into that side, but then that becomes your increased MAC valve. But we're going to feed it into this side, and that's going to make this MAC valve our increased MAC valve. So when the Holley ECU tells this to, hey, open up, we're not seeing enough dome pressure from the dome pressure sensor over here. So this is going to open up and allow air to flow in, which is going to come out the center one to the top of the wastegates, applying dome pressure on the wastegates, pinning them down. Now you got to have your boost reference from either your turbo or your intake opening up on the bottom of the wastegates, okay? And that's what this is here. It can come off your turbo or it can come off your intake. That's just so the wastegates know what your boost pressure is at, or if you're in vacuum. Now, this one over here, this MAC valve, is the decreased MAC valve. This is just going to vent air to atmosphere. So if the Holley ECU sees on this sensor over here, hey, we got way too much dome pressure, this one's going to go, okay, and it's going to open up and start venting some of that dome pressure. These two are going to work together as an increased MAC valve and decreased MAC valve to get the perfect amount of dome pressure. Now, this over here is important that it's over here, because I think I had boost fluctuations or dome pressure fluctuations and boost fluctuations because I didn't have this at the end of the line. So after you're feeding your dome pressure to the top of wastegate number 1 and then the top of wastegate number 2, somewhere after that, you need to put in your dome pressure reference. Okay, it can't be here and it can't be over here. It's got to be at the end of the line. So that's why I have it shown like this. And I think that's why my boost pressure was fluctuating, because I had it like right here before both of these. I figured it would all equalize, and it wasn't. It was falsely reading and doing weird stuff. It was doing this. So Chuck, thanks for lending a hand, and I'm sure we're going to use it in another diagram. All right, just like that, we're back with Chuck's pointer. Okay, so this is something that's important to understand about wastegates and their springs and how they work and how to understand what's actually going on and guess how much wastegate spring you actually need. So if you have one wastegate and you have 10 pounds of springs in there, it's going to net you 10 pounds of wastegate pressure, meaning the plunger has to lift up around 10 pounds of boost pressure before it starts venting. So you might actually get like 12 pounds of boost or 11 pounds of boost, or it could go the other way depending on the spring. Okay, now if you're aiming for 20 pounds of spring because you want 20 pounds of boost, right, and you put two 10-pound springs and 2 wastegates, that's only going to net you 10 pounds of wastegate. Okay, it's not going to give you 20 pounds of boost. You would need 20 pounds of spring in each wastegate. And again, if you have 3 wastegates with 30 pounds of spring total and 10 pounds in each, that is only gonna get you 10 pounds of wastegate spring. Doesn't matter how many wastegates you have or how much spring you have in each. If they're all the same, whatever the spring rate is that you put in each one is gonna be your wastegate spring pressure. Okay, so if you have 20 in each, which is a total of 60, it's not gonna give you 60 pounds of boost. It's gonna give you 20 pounds of boost. You have 10 pounds in each, even though 30 pounds of spring, you're only gonna have 10 pounds of wastegate pressure. This is important to know.
All right, let's show y'all how I got these lines ran. Let's start at the compressor in the back. So we got our compressor mounted down in here, right here, next to our 1 gallon tank. And right over here is our pressure sensor switch that cuts off the compressor. This here fills the tank, comes out the tank, goes to our regulator. The regulator regulates the tank air and then goes through the cab, and it runs all the way up to the front here where it plugs into our first increase MAC valve. Then it center branches out for dome pressure to apply to the top of the wastegates. Everything it wants to decrease, it'll vent on the decrease valve. We got three lines that run back into our firewall where we were just at. One of these lines is going to be our intake boost reference lines. This is going to go to the bottom of your wastegates. One of these is going to be dome pressure. This is going to go to the top of your wastegates. And the last one is to bring to our dome pressure sensor. And we want this at the back of the line. So after the last wastegate gets dome pressure, it will then come all the way back to a boost reference block to fill so that we can read accurate dome pressure. If you don't do it like this, your boost will fluctuate like this and your data will look like this. And also when you're on the dyno trying to pull 30 PSI, your data will look like this.
Ready?
Yep.
All right, so 151 mile an hour. But why are we at 23.7 pounds of boost? Yep, we still got some swings. So it was chilling around 29, 30, 28. Now, another super important thing to keep in mind when installing these wastegates is there's a fire ring that goes in between the wastegate and the wastegate flange, and it needs to be in there. Otherwise, you will have a massive boost leak. This is what it looks like. Make sure it's facing the right way, and it's in there. Okay, so we've gone over all the components and all the plumbing for them and routing. Now, let's briefly go over the wiring and then final part, which is the Holley Terminator X, Dominator, HP, or X-Max ECU tuning and setup. Chuck be putting in work today, boys. Alright, so your MAC valves have 2 wires each, and your dome pressure sensor has 3 wires. Let's start with the MAC valves. So you need to figure out which one's your increase and which one's your decrease. Your pressure source in is always going to go to the increase, and your vent's always going to be for the decrease. This right here goes to your wastegates. For the sake of this demonstration, I'm just going to show you with 12 volt and ground. You can put a switch in there, a relay in there, a fuse in there, you should. Alright, but for this demonstration, I'm just going to show you with 12 volt positive and ground. Alright, so starting out, one of each wires on your MAC valves is going to go to your 12 volt positive. The other wire is going to go to an output on your Holley input output harness. It's an 8-pin connector. I don't recall if it's the top 4 that are the inputs and the bottom 4 are the outputs or vice versa. These connectors are very clearly labeled. When you look at them, you'll see the E, F, G, H and the A, B, C, D. Right where I put them here, you'll be able to see that when you look at the connectors. So your connector outputs are going to be E, F, G, and H. So let's choose for our boost decrease, we're going to choose output E. So we're going to come on down to our notepad and we're going to write that down because we're going to need this later when we're tuning. Alright, so decrease equals E. And we're also going to note that harness connector position E is ECU pin B12. This is going to be important for later when we're setting everything up. So E, B12. Alright, now for our increase valve, we chose position F. So let's go ahead and write that down and write the corresponding ECU pin. Okay, and now lastly, we have our dome pressure sensor. It has 3 wires. They're usually red, green, and black, or white, green, and black, something along those lines. The red, 12 volt positive. The green is a signal wire, and the black goes to ground. So the green, we're gonna run to an input from one of the available inputs on the IO connector. We'll choose A, so input A. We're gonna write that down with its ECU connector. Now that we got all these wired up with our fuses and our relays and everything's nice and neat, we took our notes, we got our dome pressure on input A of the input side of the connector, the IO connector here, which is the ECU pin A12. Everything is wired up and we're ready to now go over to Holley and get the show on the road. Alright, before you guys can go out and rip fat, big smoky burnouts and piss off all your neighbors, we gotta set up a couple things here in Holley. So for this example, this is just a base file of some sort of LS. Let's see, what is it? It's a 6 liter. Alright, doesn't matter what liter, but I'm just letting y'all know this is just a base file. Now, your map sensor needs to be over a 1 bar sensor, otherwise it'll yell at you. I'll just go ahead and leave it at 1 bar so you guys can see it yell at you. First thing you need to do is go over to your Boost ICF tab, and if you already have it added, it'll be a turbo icon up top. If you don't see that, it's not a big deal. You click Toolbox, add individual config, go into the Boost folder, select default boost, and click open. And there it is, yelling at us because we only have a 1 bar map sensor. So we'll go ahead and choose a Holley 3.5 bar map sensor, 3 bar, it doesn't matter. Just make sure you have a better than a 1 bar map sensor later on. Now we've added our turbo ICF, and we're gonna go ahead and add one more ICF if you don't have it, and that is the IO ICF. You're gonna go, kind of went quick there. I'm gonna show y'all again. Toolbox, add individual config, IO, select default, and click open. Beautiful. So now we have an IO tab we can click and a turbo tab we can click. First thing we need to do is go over to our turbo tab, and then under system setup, select solenoid configuration, dual Holley. Control method, dome pressure only. Operating method, boost first time. Alright, for your boost safety, let's say you want to run a max of 20 psi, 20 pounds of boost. So here you're going to put something in like 25, and then boost pressure above here we'll put 22.5. All right, and the reason why we did that is if it ever touches 25 psi, we want it to revert to wastegate. Cut ignition is way harsh, and I think it does more harm than good, and just some gnarly backfire stuff. It's just harsh. Just select revert to wastegate. For boost pressure above the second option, we set to a little bit over 20 psi, just in case your system shifts into like third gear, really lugs down hard, and that boost increases a little bit over your 20-pound goal, but then comes right back to 20 pounds after a second. If you want to be careful, you can set this to 3 seconds. That way, after 3 seconds, if it's still over 22.5, it'll revert to wastegate. And what that means is it'll cut all dome pressure, and just whatever you have for wastegate spring, it'll revert down to that. All right, so that's your system setup, your safety setup, and you could set up safeties for your dome pressure. Revert to wastegate. If these are at 100. I don't know, whatever PSI, 100. I've never really messed with these. I don't think they really matter that much. But the next thing we need to do is set up an IO for your dome pressure sensor. So I'm just going to type in dome P sensor. You can type in whatever you want. Check enabled. And this is again on an input. And then we're going to select 5 volt reference because it's a 5 volt sensor. You could feed it 12 volt, but it's a 5 volt reference. The signal wires coming back into your Holley. Click configure. Under type, we'll go to, I'm looking for custom pressure. All right, sensor min is 0. Sensor max, we'll set to 100. Because that's what type of sensor I got. And now we need to scale the sensor for the calibration. So we'll go to the right side of the table, type in 100. We'll select the entire row, right click, fill row values. All right. And now each sensor should have some sort of data with it. Or even if you bought it on Amazon, they still say it. So we'll go in this table. For the voltage, we'll put 0, and for my sensor, it's 4.5 volts. And then we'll select that whole thing again, right click, fill row values, and now your dome pressure sensor is set up and calibrated, but we're not done yet. Now we need to go over to the pin map up top. Go to the pin map, get rid of this AC kick, because I don't have an AC compressor, and we're gonna look at our notes, and we put our dome pressure sensor on A for A12. That's why it's important to write that down. So we'll drag it and drop it into the input type for A12. But wait, we're not done yet. So now the system knows that that wire is your dome pressure 5 volt reference signal wire. So it knows which wire to read information off of. But we ain't done yet. So under the boost tab here, you'll see dome control setup. So we got to go to dome control setup. And now, since we're using onboard air or CO2, we're going to use the solenoid source pressure to fixed. I know it says compressor, but that's referring to a turbo. So we select fixed. We'll set the fixed pressure to 30 for 30 psi, whatever your regulator set at. I highly recommend starting at 30 psi. Under the controller setup, you may need to adjust this depending on your MAC valves, but I'm going to give you a starting point. So select custom. All right, type in 1.25 for the P term, 2.0 for the I term, and 0.5 for the D term. Start out with this and adjust these. It's kind of advanced if you have to adjust these, but this should work. Dome pressure input is the final part that ties everything together, and that's the IO we set up for dome P sensor. So we select dome P sensor, and now everything is tied together to work together. The last thing we need to do is go back to the pin map, go to view outputs, and we have to set up our boost plus solenoid and our boost minus solenoid. So you'll notice electric fan 1, 2, AC shutdown. We don't use none of that, so we'll go ahead and drag those out of there. So we're going to take and look at our notes, and we put our decrease MAC valve on connector E, which is pin B12. So decrease B12 right there. Our increase was on F, which is B11. So take the increase, B11, and right there. Click done, and that's it. Everything is set up. You go over to boost first time. If you have 10 pounds of wastegate spring and you want to try and get to 15 pounds of boost, You just throw 5 pounds in there and see what it gets. I would recommend doing something like 3 to 5 pounds to start. Go do a test strip and see what it does. If it gets you more, if it gets you less, it should work. And this is a great starting point. Now I'm gonna go ahead and show y'all one extra thing that'll help you out. If you go over to Boost and you select under trans brake launch input, you check it, set this to 10 PSI, and then go back to your pin map. You'll notice under the view inputs, there's a T-brake launch. If you wire, I don't know, oh man, how do I make that a ground? I can't remember how to make this a ground oh, okay, there already is a ground. It tells you right there, G. So if you wire a ground on a button to your A3 input on the input connector or the IO connector, it will automatically use the MAC valves to apply 10 PSI of dome pressure on the wastegates. Without the car even being on, you can test the system, make sure it's not leaking and that it's working, and then you just come in here and change this number. If you want to do 5, see what 5 PSI does, make sure this is checked. We'll put 10 pounds of dome pressure on there. You can check your system, see if it's leaking, if your compressor kicks on, stuff like that. Alright guys, this was a massive undertaking making this tutorial. But I hope it helps somebody out there understand how to do this. If this helped anybody, make sure to like, comment, and subscribe, and I'll catch you guys in the next one.